On the morning of April 28, 1988, Flight 243 began as a routine hop between the Hawaiian Islands. Cruising at 24,000 feet and 280 miles per hour, 19-year veteran flight attendant Clarabelle Lansing was walking the aisle, checking on passengers. Then, in a fraction of a second, an 18-foot section of the plane's roof vanished. There was no explosion, no collision, and no warning. Instantly, the cabin was exposed to the open sky. Passengers were hit with 280-mile-per-hour winds, the force of the air pressure pinning them against their seats as debris whipped around them. The crew faced the full brunt of the blowout. Flight attendant Jane Sato Tamita was thrown to the floor during the decompression, yet she crawled through the freezing, deafening cabin to help passengers, despite her own severe injuries. Surviving an open-air flight at commercial cruising altitudes defies the standard rules of atmospheric and aerodynamic physics. In the cockpit, the pilots heard a roar and realized the ceiling was gone. The aerodynamics of their Boeing 737 were ruined. The noise made communication nearly impossible, and they had no emergency manual for flying an aircraft in this condition. For 13 minutes, the crew wrestled the crippled aircraft down through the atmosphere, eventually bringing 94 surviving passengers to a safe stop on a runway in Maui. Once on the tarmac, the full scale of the structural damage was visible. The entire upper forward section of the fuselage had been torn away, leaving the passenger seats entirely exposed to the elements. The investigation quickly hit a contradiction. This specific aircraft had recently passed a full maintenance inspection and was legally certified as airworthy. This left investigators with a central mystery: how a fully certified, professionally inspected jet could violently tear apart mid-flight. Aviation engineers measure a plane's design life in flight cycles, where one cycle represents a single takeoff and one landing. A plane acts like a balloon. Gaining altitude, lower outside air pressure causes the sealed cabin to expand outward, then contract upon landing. Looking closer at the metal wall, we see how repetitive cycles create microscopic stress points over years of service. While engineers understood metal fatigue, the industry assumed that standard maintenance checks would spot damage long before it reached a critical failure point. In the 1980s, inspection protocols focused on finding a single isolated crack that a mechanic could visually identify and patch. Aloha 243 was riddled with thousands of microscopic cracks, each one entirely invisible to the human eye. This graphic shows the rivet holes binding the plane's skin. In multiple site damage, thousands of tiny, disconnected fractures radiate outward from these holes. Under flight stress, these micro-cracks suddenly linked together, forming a continuous fault line that unzipped the metal skin instantly. The 1980s inspection protocols were blind to systemic microscopic damage, leaving mechanics with no way to identify the true state of the airframe with the tools they had at the time. The FAA responded by mandating the first aging aircraft safety program, a set of regulations specifically designed to catch these systemic failures. This marked a shift from visual checks to non-destructive testing, a requirement to peer inside the metal without compromising the aircraft. Here, a technician uses a handheld ultrasonic scanner. Modern tools like this and eddy current testing detect internal microscopic flaws deep beneath the surface that the human eye could never see. Aircraft maintenance was upgraded from a reactive visual check into a rigorous predictive science of invisible detection. This investigation led to strict cycle-based airplane retirements and a total redesign of how Boeing assembles and inspects its fuselage panels. This evolution was forced by the tragic death of Clarabelle Lansing and the heroism of the crew who brought the surviving passengers home. Every safe commercial flight operating today relies on the microscopic safety standards and technologies born from the 13 minutes of Aloha 243.